Hello everyone. In this video, I'd like to talk about my final project. The title of my final project is Adversarial Attack on Neural Machine Translation Models as Combinatorial Optimization. There are two things you should know before we go into the topic. The first is I want to talk about neural machine translation. The broad term machine translation refers to the use of software to translate text from one language to another. Neural machine translation is an approach to machine translation with a neural network. For now, you can just assume that we have a black box which receives an input of a sentence in English and outputs the translation of that sentence in Indonesian in this case. The next part of the title is adversarial attack. Adversarial examples are inputs for the machine learning model that are designed to look normal to us humans but cause misclassification to machine learning model. A quite well-known example is this, where the left image and the right image to us humans look the same as both are pigs. But because of the small noise that are added to the left image, the right image now is classified as an airliner. Now, the motivation behind this final project is that to train a neural machine translation model, a lot of data is used. And majority of that data is written in formal English and written in perfect grammar. Training on perfect grammar dataset might predispose the model to discriminate against minorities from non-standard linguistic backgrounds. In this case, Indonesians. We learn English as a second language. We more often than not struggle with grammar and proper use of inflections. The idea is to find specific changes to the sentence grammar to fool the model. We can then use these examples and pre-train the model so that the model can, in a sense, learn from its own mistakes. Say we have a sentence in English. How do we change it? Because of the advancements in text processing, we can easily generate a set of substitution words like this. Then we can just choose the combination of words, which results in a worse translation from the original. For example, this. This problem can be modeled as a combinatorial optimization problem. Formally, let xn be the nth iteration of sentence we generate, and v is the set of substitution words of the original sentence. Now, this becomes an optimization problem with a discrete search space of the word substitution set. Now, how do we quantify the quality of translation? Say we have a data set consisting of sentences in English and its translation in Indonesian. For this final project, I use BlueScore. For the specifics, I use SacreBlue library, which is available for Python. Previous work has created an algorithm which uses the greedy algorithm to find a solution. I propose to use a different optimization algorithm, the simulated annealing algorithm. Simulated annealing, as how its name, is inspired by the metallurgy process of annealing. It is a probabilistic metaheuristic method to optimize a problem in any search spaces. To see the advantage of simulated annealing, it's quite important to know that translation process is computationally expensive. And then as we can, it is quite intuitive to see that greedy algorithm would grow linearly with the sentence length. So the longer the sentence is, the more translations or model queries we do for finding an adversarial examples. But using simulated annealing, while is more random and less raw, which results in more probabilistic result, we can set the budget for simulated annealing. So we have, in a sense, constant worst case complexity. Finally, I'd like to report a preliminary experiment result where I compared the two algorithms. Simulated annealing is better in this experiment by 6%, but it's still preliminary and there are still a lot more experiments to conduct to statistically infer that it is better. These are the two main references I use for my final project. Thank you, everyone.